Our planet is a living, breathing organism, a complex web of interconnected systems that sustain all life. At the heart of this intricate network are the elemental cycles that make life possible, including the nitrogen and sulfur cycles. But as our world becomes more industrialized and our population continues to grow, the impact of human activity on these elemental cycles has become increasingly profound. Join us on a journey of discovery as we explore the elemental impact of human activity on the flora environment. From the ways in which we alter the nitrogen and sulfur cycles through our use of fertilizers and industry, to the ways in which we can work to mitigate these impacts and create a more sustainable future. Through science, innovation, and collective action, we can ensure that the elemental cycles that sustain all life continue to thrive for generations to come. This is the Elemental Impact, a human odyssey through flora's nitrogen and sulfur cycles.
As we continue to explore and interact with different ecosystems, we inadvertently introduce the native species into the new environments. While some species may adapt and integrate into the new ecosystems without causing any harm, others can have devastating effects. These are known as invasive species. Invasive species can outcompete native species for resources such as food and habitat, leading to a decline in the native species population. They can also alter the natural balance of the ecosystem, causing irreparable damage to the delicate web of life. Invasive species can transmit diseases and parasites to native species, which can further contribute to their decline. It is important to be aware of the impact of invasive species and take action to prevent their spread. Regulations around the import and export of organisms are necessary to prevent the introduction of invasive species into the new environments. If you are traveling into a new region or country, be sure to clean your clothes, shoes, and gear to prevent accidentally carrying invasive species with you. It is everyone's responsibility to be mindful of invasive species and take steps to prevent their spread. By working together, we can help protect the delicate balance of our ecosystems and ensure the survival of our native species.
Nitrogen and sulfur cycle, inclined in anthropogenic effects, greatly influences the state of the public health and the environment. Excessive production of nitrogen contributes in changing the cycle of nitrogen, wherein activities inclined in the process leads to impurities in the atmosphere such as burning of fossil fuels, utilization of nitrogen-based fertilizers, and other activities. In the modern times, production of fossil fuels are significant in the operation of electric power generation, industry transportation, and agriculture, which led to a massive production of nitrogen oxide to the environment, causing public or possible diseases. Moreover, large-scale fossil fuel extraction that produces hydrogen sulfide alters the global climate significantly as well, which has a long-term potential effects on health hazards and resource availability. Thus, common practices that led to these influences are from oil and coal-operated power plants, metal smelters, and fossil fuels produced from heat homes, which causes massive changes to the environment, leading to acidification of water bodies and soil, causing damages and or diseases to the environment and public health. Consequently, as a student, being aware of these parameters that affects the state of the public health and the environment is significant, as in this aspect we can contribute in our own little ways on how to aid in addressing the anthropogenic effects inclined in the nitrogen and sulfur cycle. Also, by being aware of the situations on the issues that can be further addressed, as more people will acknowledge the drawbacks as provided, resulting to a securing the safety and health and risk of the public health
About
and the environment.
anthropogenic effects. Anthropogenic effects, also known as human-induced stress, refer to the negative impact that human activities have on the natural environment. These effects can range from pollution and habitat destruction to climate change and depletion of natural resources. One of the most significant anthropogenic effects is pollution. Human activities such as industrialization, transportation, and agriculture release pollutants into the air, water, and soil, which can have harmful effects on human health and the environment. For example, air pollution can cause respiratory problems, while water pollution can harm aquatic life and make water unsafe for human consumption. Another significant anthropogenic effect is habitat destruction. Human activities such as deforestation and urbanization can destroy the natural habitats of plants and animals, leading to the loss of biodiversity and the disruption of ecosystems. This can have far-reaching consequences, such as the loss of important ecosystem services like pollination and carbon sequestration. Climate change is also an anthropogenic effect that is receiving increasing attention. Human activities such as burning fossil fuels and deforestation release greenhouse gases into the atmosphere, which trap heat and contribute to the global warming. This can lead to rising sea levels, more extreme weather events, and other negative impacts on human health and environment. In addition to this example, anthropogenic effects can also include overfishing, the depletion of natural resources, and the introduction of invasive species. Overall, the cumulative impacts of anthropogenic effects are significant and can have long-lasting consequences for the natural environment and the human well-being.
Epigenetics is a field of biology that studies changes in gene expression that do not involve alterations to the underlying DNA sequence. These changes can be influenced by environmental factors and can be passed down from one generation to the next. In the context of the nitrogen and sulfur cycles, epigenetic changes play a critical role in regulating the activity of microorganisms that are involved in these biogeochemical processes. The nitrogen cycle is a complex process that involves the conversion of atmospheric nitrogen into organic forms and can be used by plants and other organisms. The transformation of ammonia into nitrite and then nitrate by a class of bacteria known as a nitrifying bacteria is one of the crucial steps in this process. These bacteria's ability to carry out this function may be impacted by epigenetic modifications which could vary the rate of nitrogen cycling as a whole. Additionally, sulfur plays a significant role in biogeochemical cycles and is necessary for the synthesis of a variation of organic molecules including protein and amino acids. The sulfur cycle is like the nitrogen cycle is controlled by a complex network of microbes that perform a variety of distinct metabolic processes. The availability of this crucial nutrient can fluctuate as a result of epigenetic changes in these bacteria that influence the sulfur cycle. In summary, epigenetic modifications are essential in controlling the activity of microorganisms engaged in the nitrogen and sulfur cycles. These modifications may have an impact on how genes involved in these crucial biogeochemical processes are expressed, which may modify how quickly nutrients are cycled overall. Understanding the processes of epigenetic regulation in these microbes will help us create novel strategies for controlling these crucial biogeochemical cycles and eventually for preserving the health of ecosystems.
Biogeochemical cycles are critical to the existence of life, transforming energy and matter into the usable forms to support the functioning of ecosystems. These cycles describe the movement of matter between the major reservoir of Earth, the atmosphere, the terrestrial biosphere, the oceans, and the geosphere. The six most common elements comprising organic molecules, the backbone of life forms, are carbon, nitrogen, hydrogen, oxygen, phosphorus, and sulfur. These elements reside in the different reservoirs to different extents and consist of a variety of chemical forms, both organic and inorganic. As mentioned, there are 6 different kinds of biogeochemical cycles. with this. One of it is the carbon cycle. Carbon is an essential element in the bodies of all living organisms and an essential source of energy for many organisms. The movement of carbon through the environment occurs on a variety of temporal and spatial scales. To conclude, biogeochemical cycles are important in distributing nutrients between the different spheres of the Earth, which allows the Earth's biome to prosper.
The elemental cycles that sustain all life on our planet are fragile and interconnected, and it's up to us to protect them. Through our actions, we can create a more sustainable future where these cycles can thrive and flourish. We hope that this journey through the elemental impact of human activity on the flora environment has inspired you to take actions and make a positive difference in the world around you. By working together and taking steps towards a more sustainable future, we can ensure that these elemental cycles continue to sustain all life for generations to come. Thank you for watching, and remember, every small action counts towards a greater good.